Good day, everyone. My name is Ryan Joshua Di Castro, and I am student 29. I'm going to continue the report of the previous reporter, which is about the open channel flows. Specifically, my report is about the gradually varied flow and the rapid varied flow. So before we proceed to my topic, let's just have a short recap about the previous discussion. So open channel flow, it is a type of liquid flow within a conduit, channel, or waterway with a free surface known as a channel. So examples are streams, lakes, and culverts as long as they are not filled or hindi sila puno. And the past reporter, he talked about the introduction for the open channel flow and about the uniform flow. In my report, I'm going to talk about the non-uniform open channel flow, which we have two, the gradually varied flow and the rapidly varied flow. So what is a non-uniform open channel flow? The velocity and the other hydrodynamic parameters changes from one point to another when the flow is defined as non-uniform. The cross-sectional area, depth, and velocity may vary along the channel. So compare sa uniform flow. In uniform flow, we do not consider the inertia forces, where in non-uniform flow, we consider the increase and decrease of in the velocity of the flow. And also in non-uniform flow, unlike sa uniform flow, which is the flow is stable or it is uniform throughout the channel. So non-uniform flow is we have slopes, bed slope and energy grade line slope will naka-affect sila sa flow depth and the velocity of the water. So for the first part of my report, I'm going to talk about the gradually varied flow in open channels. Gradually varied flow is defined as steady, non-uniform flow in a channel in which there are gradual changes in water depth. The losses are negligible. The loss of energy is mainly due to boundary frictions. Gradually varied flow is a change in flow depth through space. So in the gradually varied flow daw is in the channel is syempre it is non-uniform. We are experiencing changes. Sa gradually varied flow, the change in the flow rate and the velocity, it happens very slowly, gradually in the whole channel. And also, ang energy loss natin is only due to boundary frictions. The head loss is negligible or hindi siya sinasali sa calculations. So, here's a sample formula for solving the slope of the water surface, which is bottom slope minus friction slope all over 1 minus Freud's number squared. It is equals to the slope of the water surface. So if you refer to this image at the right side, you can see na kaning sa baba, muna yung bottom slope SO and sa taas, this is the friction slope SF. Bali, this formula also is, the assumption is, it is for a rectangular channel. So for the formula of the gradually varied flow, the Freud's number and the friction slope SF values are always positive. And the bottom slope or the SO, it is positive for downward sloping sections. Refer to this image at the right side. This is a sample of a downward sloping section, steep slope. The SO is 0 for horizontal sections or a straight line. It is negative for upward sloping sections or what we call the adverse flow. So next we have the results for gradually varied flow. Bali, the trend of this formula is the flow depth. The flow depth depends whether it increase, decrease, or remain constant. It depends on the what do you call this, the sign of the dy over dx. So when the dy over dx is greater than 0, the flow depth increases. when the dy over dx is less than 0, or if the dy over dx is negative, the flow depth decreases. And if the dy over dx is equals to 0, meaning the flow depth will remain constant, and thus SO is equals to SF. Bali, in this case, we will have a horizontal slope because the SO and SF is equal. So why is it important? Why do we need to study the depth of flow in various areas or spot in open channel? So open channel systems are designed and built on the basis of the projected flow depths along the channel. Therefore, it is important to be able to predict the flow depth for a specified flow rate and specified channel geometry. So yun na nga, when we design open channels, ang basis natin is ang flow depths along the channel. That is one of the bases. Next is we have the gradually varied flow surface profile. A plot of flow depths give the surface profile of the flow. The general characteristics of surface profiles for a gradually varied flow depends on the bottom slope and the flow depth relative to the critical and normal depth. So when we designate or label surface profile, nagadepende yan sa ating bottom slope and flow depth. So to further explain this, here we have the gradually varied flow surface profile. As you can see that the slope, it can be steep, critical, mild, horizontal, and adverse, and you can label that as SC, M, H, and A. So the channel slope is mild or M when the normal depth is greater than the critical depth. Normal depth is Yn and critical depth is Yc. So the channel slope is steep if Yn is less than Yc. It is critical if Yn and Yc is equal. It is horizontal if our SO or the bed slope is 0. Therefore, we have a 0 bottom slope. And it is adverse if SO is has a negative value. Therefore, we have a negative slope. So for the numbering, para sa types ng flow, is referred to this image at the bottom right. So if the, what do you call this? If the flow depth is greater than the Yn and the Yc, therefore it is labeled as number 1. If it is between Yn and Yc, it is number 2. And if it is below the critical depth, then it is labeled as number 3. So here's an example. So considering this image right here, as you can see, we have 3 different depth of flow, the M1, M3, and M2. So the assumption is that Yc is less than Yn. So if you refer to this table, the previous table, Yc is less than Yn or Yn is greater than Yc. So it is a mild slope. So for the channel slope, we have mild. That's why it is labeled as M. And for the flow depth, for number 1, Y is greater than Yn. So refer to the past slide. You can see that if Y is greater than Yn, then it is number 1. That's why it's labeled or designated as M1. Same with this M2 and M3. So for the second part of my report, I'm going to talk about the rapid varied flow in open channels. Rapid varied flow. It is another type of non-uniform open channel flow where the fluid depth changes rapidly over a small reach of the channel. So compare sa gradually varied flow, where in the gradually varied flow, the flow is steady. The changes in velocity and water depth, it varies very slowly and gradually all throughout the channel. Sa rapid varied flow naman is it happens instantly, parang biglaan. So the fluid depth and the velocity can change instantly. So what we call this event is these are called hydraulic jumps, kanang biglaan na increase sa flow depth or velocity. Hydraulic jump occurs when the flow changes suddenly from supercritical to subcritical flow. This is often accompanied by extreme turbulence and high energy losses, and also compares a gradually varied flow where the main energy loss nato is due to friction. Sa rapid varied flow is it is accompanied by a high energy loss. So in classifying hydraulic jumps, we can classify it based on two options or methods. Number one is based on Freud's number, and number two is based on tail water depth. So for the classification of hydraulic jump based on Freud's number, we have this image right here. If the Freud's number is in between 1.0 to 1.7, we have the angular jumps. If the Freud's number is between 1.7 to 2.5, we have a weak jump. And if the Freud's number is 2.5 to 7.5, it is an oscillating jump. If the Freud's number is 4.9 to 9.0, it is a steady jump. This steady jump, this is considered the most optimal when you design a channel. It also have the best performance when regards sa hydraulic jumps. And lastly, if the Freud's number is 9.0 or greater than 9, it is considered a strong jump. Next is we have the classification of hydraulic jump based on the tail water depth. First, we have the free jump. The jump with YT equal to or less than Y2 is called a free jump. YT is the tail water depth and Y2 is the sequent depth to YA, which is kaning depth sa vena contracta. When YT is equals to Y2, a free jump will form at the vena contracta. So when YT is equals to Y2, it is a free jump. Next, we have repel jump. If YT is less than Y2, the jump is repelled downstream of the vena contracta through an M3 curve or maybe an H3 curve. So regarding this M3 and H3, as I've discussed earlier, kani sila is designation para sa type of flow. M meaning it has a mild slope, while this number 3, it means that the flow depth is less than the critical flow. So similar sa H3, meaning it has a horizontal slope with a flow depth less than the critical depth. The depth at the toe of the jump is larger than YA. Such a jump is called a repel jump. So this repel jump can be also considered a free jump because it satisfies the equation YT, which is less than Y2. And lastly, we have the submerged jump. If YT is greater than Y2, the jump is no longer free but gets drowned out. Such jump is called drowned jump or submerged jump. The loss of energy in a submerged jump is similar than that in a free jump. So as you can see in this image right here, the YT is much greater than the Y2, and also the level of water is above the kani-kaning opening sa there is opening. It's just mas taas siya. So here we have a formula for the hydraulic jump and our rectangular channel. Considering this specifications, dapat rectangular cross section with the base width of B and the initial height of Y, and also the flow rate is equals to Q times the base, and area is obviously times B times Y. Also, we have this assumption that B1 and B2, which is this is murag different spot or different area sa channel, meaning that uh, ang base natin all throughout the channel should be the same or assumption para din na formula. So for the formula of the depth before and after the jump, by the way, kaning y1, this is the depth before the jump, y2 is the depth after the jump. So here's the formula. We have this formula. And also, similarly, if gusto nyo kunin ang y1, all you need to do is you need to swap, kanang change the value of y2 to y1 and likewise y1 to y2. So for example, this formula, aning sa baba, say you want to find the y1 tapos y2 ang given. Bale, kaning formula is mahimo na ni siyang y1 is equals to negative y2 over 2 plus the square root of y2 over 2 squared times quantity 1 plus 8 v2 squared over gy2. So, mura na siya. I-change lang nimo ang y2 to y1. And lastly, for the energy loss in a jump, we have the HL is equals to y2 minus y1 cube all over 4 times y2 times y1. As I've said na unlike sa gradually varied flow, in a rapid varied flow is we have a energy loss. So that concludes my report. Thank you so much for listening. If you have any questions, you can email me or pwede ko ninyo i-chat. That's all. Stay safe and stay healthy.